If you like this video, please press the subscribe button to subscribe to this channel, and also give it a thumbs up. On August 17, 2017, the merger of two neutron stars into a black hole was detected in a galaxy 130 million light-years away by gravitational wave detectors. The signals detected included the production of heavy elements, including enough gold to exceed the mass of the Earth's moon. As a consequence of this discovery, it was concluded that the mystery of how the heavy elements could be produced in the Big Bang had been solved. The process starts when you have two neutron stars orbiting close to each other. Because of the emission of gravitational waves, the neutron stars spiral into each other over time. Eventually, they reach the point where they collide. This results in a supernova that produces a cloud of dust and gas that sends any elements produced into space. There is a problem with this conclusion. It turns out that subsequent observations have not produced the same results. Despite better equipment, none of the subsequent observations produced the same heavy elements. This is sufficient data to demonstrate that the earlier results would be insufficient to produce sufficient heavy elements. The first explanation suggested is that the neutron-star merger rate was larger in the past. The problem with this idea is that it is essentially untestable. Our gravitational wave detectors are not sensitive enough to detect gravitational waves far enough away to test it, and this is unlikely to change. Explanation number 2 is that extremely bright supernovas produce large amounts of heavy elements. While this is a good environment for producing elements beyond iron, to work it would be necessary to produce detectably large amounts in such rare cases. Observations made of the supernova remnant of an extremely bright gamma-ray burst on October 9, 2022, using the James Webb Telescope data, falsified this idea. Explanation number 3 is that heavy elements formed in normal stars by neutron capture. This is a process that is well understood, and it can produce heavier elements by beta decay. However, in main sequence stars, the process would be too slow to build up large elements because they would decay too quickly. It is only in rapid bursts that occur in events such as supernovae where the process is fast enough to do the job required of it. In conclusion, the difficulty of producing sufficient heavy elements in the Big Bang cosmology is one of its many difficulties. The failure of ways to solve this problem makes it even worse. Perhaps the real question is the validity of the cosmology being used.